Have you ever been at the beach or harbor, looked out at a massive steel ship and just wondered, how on earth is that thing floating? It just seems like it should sink straight to the bottom, right? Well, today, we're going on a science adventure to solve that exact mystery.
It's a total head-scratcher when you really think about it. You can take a tiny little coin, drop it in the water, and whoosh, it's gone. Sinks like a stone. And yet, these enormous cruise ships weighing more than thousands of cars combined, they just bob along on the surface. It feels like it breaks the rules of physics.
So yeah, this is the big question. How can this small, lightweight coin just plummet to the bottom, while this ginormous ship with thousands of people on it floats so easily? It turns out there are some really cool scientific secrets at work here, and we're about to uncover every single one.
Okay, our first clue in this investigation is a really important one. It forces us to look past the most obvious answer. See, it's not just about how heavy something is. We need to talk about two words that seem similar but are actually very different: heavy and dense.
You know, the first thing everyone thinks is, well, heavy things sink and light things float. And I mean, that makes sense sometimes, but it's not the whole story, not even close. There's a secret ingredient, a special property that explains everything.
And that secret ingredient is density. This is just a sciencey way of asking how much stuff or matter is crammed into a certain amount of space. It's not just about the weight, it's about how concentrated that weight is.
To picture this, imagine you have a big box and you fill it all the way to the top with fluffy feathers. The box is totally full, right? It takes up a lot of space, but there isn't actually that much stuff packed inside. That's low density. Now, let's take that exact same box, but this time we're going to cram it full of heavy rocks. We're packing in a ton of stuff into that same amount of space. This is high density. Same size, totally different amount of material inside.
So here's the golden rule, the thing you have to remember. It all comes down to comparing an object's density to the water it's in. If it's less dense than water, it floats. If it's more dense than water, it sinks. That box of feathers, way less dense. It floats. The box of rocks, much more dense. It sinks, no doubt about it.
Okay, but density is only one part of the puzzle. There's another amazing force at work, a kind of secret superpower that water has. It turns out, whenever you put something into water, the water doesn't just let it happen. It actually fights back. It pushes.
And the secret upward push has an official name: buoyancy. Think of it like an invisible helping hand that's always pushing up on anything in the water. It's a force that works against gravity, trying to keep things afloat.
And believe it or not, this idea was figured out more than 2,000 years ago by this brilliant Greek scientist named Archimedes. The story goes, he was trying to solve a problem for the king, and he hopped into a full bathtub. As he got in, he saw the water spill over the sides, and suddenly, bang, it clicked. He realized the water was pushing back on him. He was so excited, he supposedly ran through the streets yelling, "Eureka!" which means, "I found it." And that whole bathtub moment perfectly shows our next key idea. For your body to get into the tub, some of the water had to move. You literally pushed it out of the way. The science word for that is displacement. Anything you put in water displaces or moves some of that water.
Now, this is the really mind-blowing part that Archimedes figured out. The strength of that upward push, that buoyant force, is exactly equal to the weight of the water that the object pushed away. So the more water you displace, the bigger the upward push you get in return.
All right, it's time for the big reveal. We have our two major clues: density and that upward push called buoyancy. Now we're going to put them together to finally solve the mystery of the floating steel ship. And the answer, you'll see, is all about the magic of shape. So let's start with just a solid cube of steel. No tricks. We know steel is way denser than water. So what happens when you drop it in? Plunk, it sinks straight to the bottom. No surprise there, it's following the density rule. But what if we took that exact same amount of steel, but instead of a solid block, we changed its shape? What if we flattened it out and curved it into a huge bowl, just like the hull of a boat? Suddenly, that one simple change makes all the difference. The shape is the secret sauce.
Because look, a boat's hull isn't solid. It's hollow. And what's inside all of that empty space? Air. A whole lot of super-duper light air. And air has an incredibly low density. And this brings us to our final and maybe most important concept: average density. See, to figure out if the boat floats, we don't just look at the density of the steel.
We have to look at the density of the whole object. That's the steel and all the air trapped inside it.
And that is the solution. The huge amount of trapped air makes the boat's average density way, way lower than if it were solid steel. In fact, its average density becomes less than the density of the water. So now the buoyant force pushing up is stronger than the force of gravity pulling it down. The upward push wins, and the boat floats. It's that simple.
So there you have it. Mystery solved. It's not magic, it's just amazing science. Now, just to make sure all this information sticks in your brain, let's do a super fast recap of the 5 key ideas that officially make you a boat expert.
All right, here are your 5 keys to floating. Number 1, water always pushes up with a force called buoyancy. 2, things float if their overall or average density is less than water. 3, when you put something in water, it pushes water away. That's displacement. 4, that upward push from buoyancy is equal to the weight of the water you displaced. And the big one, number 5, a boat's hollow shape is the secret. It traps air, which lowers its average density and lets it float.
So now that you're an expert in all this, here's a fun challenge for you. Go find a piece of aluminum foil. If you scrunch it up into a tight ball, it's dense and it'll sink. But now that you know the secret of shape, what kind of boat can you design? Can you build one that not only floats, but that can even carry a few coins? Give it a try. Thanks for exploring with us today.